In our next section, we're going to talk about some more polynomials, but we're going to learn one of the key things that is going to be essential for your future academic careers with pre-calculus and or foundations. So first things first, we're going to talk about some review. So different parts of polynomials, they tell us a few different things. So if we have a polynomial like 5x squared minus 2x plus 1, we're going to talk about 4 different things. We're going to talk about term, degree, leading coefficient, and the constant term. Now, I'm not going to expect that you memorize those definitions, but you do need to know what they are. So first thing, what is a term? Well, a term are numbers and variables separated by addition or subtraction. So for example, in this specific case, one of our terms is 5x squared. Another one of our terms is a negative 2x. And another one of our terms is a positive 1. So we do have 3 terms because they are separated by addition and or subtraction. The degree is the highest power of the variables. If there's 2 or more variables, you have to actually add the exponents. Now that's talking about if you by chance had something like this, you would add the 2 and 1 and it would actually have a degree of 3. A lot of things that we're going to be doing don't actually have a double variable thing anymore. That's more of an older curriculum style question. In this case, our highest power here is 2. It's the highest exponent. The leading coefficient is the number in front of the variable with the highest degree. So in this case, it would be the number positive 5. That would be our leading coefficient. A coefficient are just any kind of number that's in front of a variable. The leading coefficient is 5. And the constant term is a number without a variable. In this case, 1. So we're going to talk about 2 processes. So for example, if we had 2 bracket x plus y, we would naturally want to follow exactly what we had done in our multiplication section. 2x plus 2y. Now, this process is called expanding. In other words, we're multiplying. The process that allows us to do this is distribution. But if we went backwards, we went from 2x plus 2y to 2 bracket x plus y, this process is called factoring. Now, factoring is like division. It is not actually division, it's just like division. So the biggest thing though to know is that when we're doing this factoring, the number that is on the outside is known as the GCF, our greatest common factor. This is where knowing how to factor in, knowing what factors are, comes into a very key part. Now, to factor is to take out what is common from each term and put it out in front, just like when we converted from an entire radical to a mixed radical. So what I'm talking about is when we have the square root of 45, well, that's the square root of 3 times 5. To go from an entire radical to a mixed radical, we look for that group of 2. And we have 3 root 5. It's, in all practical sake, it is a form of factoring, what we just did here. Now we're going to do the exact same type of thing. Our first example is we're going to find the greatest common factor for these. So for 12 and 18. Now, of course, we know how to do it. 12 is 2 times 3. 18 is 2 times 3. So we look for what is common. Well, it's a 2 and a 3. which is 6. Of course, you'll have to do some of these more basic ones in your head on a very quick basis. At the same time, when we start dealing with things that have variables, we have to be even faster. But at the same time, sorry. What we need to do is we need to be very conscious of what each of these things are saying. Well, in this case, this is 3 times x squared times y cubed. This is 6 times x cubed times y. In other words, this is 3 times x times y times y times y. This one is 6 times x times x times x times y. So what is our greatest common factor? Well, a 3 has a 3. A 6 is a 2 and a 3. So our greatest common factor numerically will be the number 3. But how many x's are the same? Well, in this case, there's 2 x's. In this one, there's 3. The total amount that's common would be 2 x's. If there's 3 y's here and there's 1 y here, the amount that is common would only be 1 y. And in our last one, 15x cubed, 10x squared, and 35x, our greatest common factor, there's a 5 common in all of them. 15 is 5 times 3. 10 is 5 times 2. 35 is 5 times 7. X cubed, x squared, and x, the only thing that is common between all of them is just 1x. We can't say there's an x cubed because there's not 3 x squared or x's in this 35x. There's only one that is common in all of them. So what we're going to do is we're going to do some greatest common factoring and actually factor. In this first example, we're going to take this greatest common factor and factor it out. So factoring is like division. So when we tie back our understanding of what we had done in grade 9, our greatest common factor between a 12x and an 18, our greatest common factor is 6. Actually, I'm just going to move that right up there. And I'm just going to write GCF. GCF. So if our greatest common factor is 6, what we're going to do is we're going to divide, in quotation marks, each of our terms by 6. So we're going to divide that one by 6. We're going to divide that one by 6. But notice how when I factor up here, a 2 is common in each of them, but that 2 just comes out in front. So in this one, if I have my 12x divided by 6, I take my 6 out in front, and I take 12x divided by 6. Well, that's going to be a 2x. 18 divided by 6 is 3. If I were to, by chance, expand to check, so again, this is our final answer. This is what we want. But to check, 6 times 2x is 12x. 6 times 3 is 18. We get right back to the same step. So expanding and factoring are actually opposite processes. How about our next one? Our greatest common factor between 3x cubed, a 5x squared, and an x. Well, the only thing that's common is an x. So if we divide each of our terms by x, that x goes out in front. 3x cubed divided by x, same base dividing, well, we would subtract the exponents. 3 subtract 1 is 2. 5x squared divided by x would be a 5x, because x squared divided by x, 2 subtract 1 is 1. Here is the tricky part, and this is something that some people do neglect. X divided by x is not 0. Anything divided by itself is 1. The only reason it's a negative 1 is because of the subtraction. Sorry, that was a hiccup. Of course, we could distribute and check to make sure that our answer is the exact same, but it would be. Our greatest common factor between 36x to the power 4 add 24x squared subtract 60, the only thing common is 12. There's no x's that are common. So if we divide each of our terms here by 12, we put that 12 out in front. Again, factoring, we take that number and put it in front. We'd be left with a 3x to the power 4, adding 2x squared, subtracting 5. And that's factoring. That's great. That is factoring by the greatest common factor. Now go have fun.